Okay, is it visible? Can someone please confirm?
Yes.
Yes, sir.
Okay, thank you. Okay, so today's topic is Apache Airflow demystified. So let's start with the history of the Airflow. Airflow has born in 2014 in Airbnb, where Airbnb's data engineers was trying to do so many, trying to accomplish so many things using the data pipelines. But the issue was there, there were too many things, some task is going to be failed, so monitor it. Some tasks need to be run twice in an hour, some tasks need to run once in a year. So managing all these things was like very difficult. So they had started one like open source project, and after that project was acquired by Apache, and it is called now Apache Airflow. Some of the community is like majorly working on the Apache Airflow, and some background companies of the Apache Airflow is continuously trying to improve it. And there are lots of people who are continuously working in this open source technology to enhance these things. Latest version of Airflow is 2.3. I will go through so many things inside these slides. Okay, so like if you have some questions, please park it in your notebook and we will discuss everything at the end. Also, reminder is that keep in mind that each and everything is going to be asked in the last quiz. So whenever you are seeing any slide, just keep your mind awake. Okay, and also like it is a morning time, so take your tea and start learning with me. Today's agenda is like I'm going to discuss what is Airflow, its components, operators, applications, limitations, and we will end with demo. I will try to more focus on the UI part and demo part. Okay, so let's start with some very basic intuitions behind this Apache Airflow and what is this data pipelines. This is like buzzword in the data engineering and data science side. So please start reading these slides yourself. Also, I will going to explain you. Let's say there is one client and he comes to you and there is such requirement he has given to you. You have to do something out of this. You have to build some solution. So what you will do that client said query your metadata database to decide if the batch jobs should be run today or not. Okay, so when I'm talking data pipelines, right? So just understand it. Uh, Whenever our software engineering task is done, so we are putting our data into some relational databases, right? So like PostgreSQL or SQL Server or MySQL, whatever. After the task is started for data analytics purpose and data science side. Okay, so once the data is stored in the SQL, now we have to found out some truthful data, some metadata out of them, and we want to build some kind of machine learning models. We want to do some kind of analysis on the top of that. So this is the task. Okay, so what happened is that like if your data analytics or data science system requires some kind of data, right? And they want such kind of data, like some tasks should be run at 3 a.m., some tasks should be run at 4 a.m. If something is going to be missed, it should be noticed to you on Slack or Microsoft Teams that this task is failed. You have to rerun this task. Okay, so when I'm talking like some tasks should be run at 3 a.m., so it should be run at each at 3 a.m. or every day 3 a.m. Some tasks, so it's totally cron based scheduler, right? So you can decide whatever as per your data frequency. Something should be run at every 1 hour, right? So let's say there is data science team or data analytics team is continuously watching your data. They are doing continuously monitoring that. So they require such kind of data frequency. Uh, if the data is arrived on time, move the data to high storage. If not, retry until 7 a.m. So this is different conditions, right? If your task is started at midnight, you have to retry it until 7 a.m. After that, if it is not, then you make it as a failure. When all files are in the place, submit a predefined Spark job. So task is that like let's say there is SQL server, your data is there. Now you have to get the data out of that SQL server to your Hive. You have to do some kind of transformations when you are storing into the Hive storage. Hive means like it is another kind of storage, but it is for big data storage. So it is like very efficient. On top of that, you want to do some kind of Spark job or machine learning job, any kind of things, right? And when success signal is returned from Spark, write a record to your logs. So this is like some kind of requirements by your client, what you will do. So many times it come in my mind that why I go with Airflow. Yeah, this is a simple task. I can achieve these kind of things with Python, cron job scheduler, and some kind of scripting. Okay. But what happened if you have hundred of workflows such of these? Okay, some requires yearly runs, some require daily runs, some requires hourly runs, right? You have to manage everything. You have to manage, monitor each and everything. If something is failed, you have to. It should be automatically retried. If this is the kind of scenario, what happened? Okay, so you cannot manage everything using this simple solution, right? So here you will require lots of man hours. Here you will require to continuously keep watch and tracks. You have to watch different logs, what happens behind the scene. So this is the thing, like particularly you have to keep in mind when you have hundreds of workflows to manage. Okay, so what is airflow? I'm talking so much about intuitions. Now let's go to the airflow. Okay, something funny is there. एयरफ्लो सुन के हवा का एयरफ्लो सुन के हवा का झोंका समझे क्या? एयरफ्लो नहीं तूफान है हम. Okay, so in a nutshell, if I will talk about the Apache Airflow, so it's an open source tool to programmatically author, schedule, and monitor workflows. It is one of the most robust platform used by data engineers for orchestrating workflows or pipelines. So when I will say orchestrating, so orchestrating means that you have to manage thousands or hundreds of data pipelines in a single dashboard. You should be able to filter it. You should be able to monitor which one is running, which one is in retrial state. This all these things is visible to you on Apache Airflow dashboard. So this is called orchestration. You can easily visualize your data pipelines, dependencies, progress, logs, triggers, tasks, and success status. So all these kind of things, it is visible in a single dashboard. Some of the core features, I will say that Apache Airflow is like easy to use. First, if you have some basic Python knowledge, you can jump into it. There is no required much like expertise of anything. So based on your requirements, like if you are going to work with Apache Airflow and AWS, of course you will require AWS knowledge. If you are going with GCP, you will require GCP knowledge. But the basic thing is like you should have a basic understanding of the Python only, nothing else. Open source, it is free and open source. I already talked like there is a large community and lots of open source contributors who are continuously contributing to the new upgrading versions. Robust integrations. You can integrate these things with anything, GCP, Airflow, any cloud, AWS or IBM cloud, or you can do like whatever kind of work you want to do with data specifically. So it will can be ready to operate with Google, everything, right? Microsoft Azure. Use standard Python to code. Okay, so there is no like any kind of latex Python or C Pythons or J Pythons, right? You have to just use just standard Python or code. If I will talk with Apache NiFi, if someone has already worked in Apache NiFi, so Apache NiFi has Python, Java plus Python. So it is a little bit complicated. You cannot like a plain Python code inside that. But here the features of Airflow is that you can write a plain Python code. Like even you can write simple hello words kind of coding and it is going to be execute that. Amazing user interface. Of course, we will going to talk more about this. I will show you each and everything inside the UI. Okay, again, why Airflow? So dynamic. So dynamic when I will say the dynamic. So it is like very dynamic. You can write something by code. Okay, so you have to just define some kind of coding like I want to create this many tasks of this type. So it will automatically do this kind of DAGs. I will talk about that DAGs. So it's dynamic. You no need to write each and everything. Okay, you have to just write some kind of codes and it is going to be create DAGs for you. Scalability. So it has a infinite scalability as per the documentation. So you can scale it at any level. Shiny UI, of course, and extendability. So in some cases, it might be happen that something is not available in the ready-made or executors or operators. Okay, so you can define your own operator. Let's say something new technology is coming and there is no inbuilt operators for that. So you can define your operators. You can define your hooks. So hooks like if you want to attach your airflow with Microsoft Teams or Slack. So you can write some kind of codes on top of that. So it will hook this Airflow with Slack. Extendability, like if something is totally new technology, let's say AWS has introduced SageMaker for data scientists and no any other operators is available in the Airflow. So you can write your code. So it is like just kind of open source technology. You have to just extend some kind of its operate page operators. You have to enhance its feature functions. You have to implement this all these kind of things. So you can easily extend the thing. So you can use your on operators. Okay, DAG. So DAG, if you are like a big data engineers, you might be heard that DAG. So DAG, what is DAG? So in simple terms, it should not have any kind of looping mechanism. Okay. So when it's flowing, data is flow from one direction to another. It should be one direction only. So if I will talk, let's say there is one Python operators. It is doing some kind of Python task. On top of that, there is SSH operator, which will going to be run some kind of scripting, SS scripting, shell script. This is some operators. I will go to it about the operators. So let's say there is the custom operator which I was just to talk. So if something is not available, you can write custom operator on top of that. So this is the different type of operators. This all this going to be parallel execution. Once this all done, again the high operators will come. So you can see here there is no any kind of looping. Everything is in one direction, starting from here to here. If something is failed, other task will going to be run. This is the trigger rules. Here you can define like some kind of things like if everything is done, then only execute this. If single one done, then execute this. So this is a different trigger roles. We will talk about this later. So I hope that you guys understand what is DAG. So DAG means that it doesn't have any kind of looping. It has some kind of dependencies. Here, let's say there is a training model A, training model B, training model C. You have to choose best model out of that, and you will say that it is accurate or inaccurate. Okay, so it is like one way, one direction flow. If something is failed, then it should be stopped over there only. At heart of the tools is concept of DAG. DAG is a series of tasks that you want to run as a part of your workflow. So this is the workflow. Okay, when you are going to something execute the all the things for particular one set of tasks. So this is workflow. Operators. So here you can say the different operators, Python operator, custom operators. So what is this operators? So there are total three type of operators in Airflow. One is action operator, transfer, and sensor. Action operators is responsible for doing some kind of actions. Like if you are using a Python operator, so Python is going to be do some kind of actions. Transfer operators, when you're transferring some data, like let's say you want to transfer data from Postgres equal to S3 or Hive to S3, such kind of things can be done using transfer operator, particularly when there is a data transfer task is there. Sensors. So sensors is one kind of task which will continuously working, continuously monitor something, right? So in a layman term, like whenever we are saying that this is a temperature sensor or this is humidity sensor, so what it will do? It will continuously run, it will measure something, and it will give a feedback, or it will give you some kind of output that this is a temperature at 9:10, this is temperature at 9:15, right? So it will going to be run continuously and it will producing some kind of task. Okay, you can also define some kind of things like if some event is occurred, it should be stopped. Or you can define that it should be work only for 1 hours. So this is the sensors. In Airflow terms, when I will set sensors, I will going to show you one example, S3 bucket. So it will continuously wait for some files inside the S3 bucket. If I will put that file inside S3 bucket, this sensor is done. So this is called a sensor. Here some inbuilt operators of Airflow. There are lots of lists with the different clouds with different technology. You will find near to 500 plus Airflow operators. So this is a sample. When I was talking like Apache Airflow operator, some Bash operator. If you want to execute some Bash script, branch operator, date time. Email operators, right? Like if something is going to be fail or if something is going to be success, you want email, so these email operators will work. Then okay, GCS to S3. So these are transfer operators. Google API to S3 transfer operators. So these are different operators. There is also like S3 census operators, which is workforce sensors. Okay, when I was talking like operators and task, okay, so there is some questions like what is exactly the operators and what is the exactly the task. So this is a simple example. Let's say there is one database you want to connect with the database, right? So first you have to get instance of that DB, and after that you want to insert something inside the DB. So what you will do that this is a simple code, right? Either you can write in the C# or Java or any language or PHP. Most of the engineers writing in this way. Okay, so this is operators code. Okay, when this operator's code is going to be like execute, so it's called a task. Okay, so this is one task. I will write that I want to connect with database. So this is one task for Airflow. And when it is going to be run, right? So let's say it is going to be run 24 times in a one day for every 1 hour. So this is called a task instance. So I can say that this is run on 2nd of February, 9 and 1 a.m. in the morning. So this is one instance. So instance is like we can say that class instance, right? In terms of Java or Python or C Sharp. And task is like we can say that some kind of things, some kind of task that functions you want to execute on top of that. Workflow. So workflow is like combination of everything: task dependencies, DAG, this all these operators. So once like one set of thing is that one DAG is that like you are waiting for something. If it is done, it is going to be executed. So this all these things is combined is a workflow. Some core components of Apache Airflow. So there are so many things is going behind the scene. One is like web server, scheduler, metadata database, executors, and worker. Okay, so first time like whenever you are going to install Airflow in your local system, either in Docker or some other stuff, either some other way, what things it's required. So one is web server, scheduler, metadata, and all these things. Web server is for showing the UI. It is like a Flask based web server where Flask is like a simple REST API in the Python. Okay, so it has some kind of UI. It will provide you some UI. Scheduler. Scheduler is responsible for scheduling the task. Metadata database. So it is mostly people are using either PostgreSQL or SQLite as per the documentation of Airflow. So metadata, it will store all the kind of things like how many DAGs, what DAGs is run, how many DAGs is failed, success. So all the things will be stored inside this. Executors. So executors, you can say that in terms of Java, this is a JVM. Okay, so it is providing you some kind of environments for running your applications. Workers, so workers is end task or end node, which is going to be execute this task. Scheduler. So this is a main responsibility of schedulers, scheduling a graph of dependencies. So when you are defining a DAG, so it will show the dependencies where workflows. So workflow is a DAG of task, handle task failures. Scheduler is responsible for if something is failed, then you can define that retries and all these things. Report or alerts on failure. If something is failed, it can report on Slack or it can report on the email or whatever the things you are using in Skype, right? Monitor performance of the task over the time. So if there is different charts, there is already charts I will show you. You can monitor all these things over the chart, like which task required how many hours or such kind of things. Enforce SLA. So SLA is service level agreement, right? So if your client required that something should be run within 1 hours, but your DAG is taking 2 hours, so something is wrong. So you can define that SLA. So SLA, why like once it is going to be break, it will give you message in Slack or email that this SLA is break. You have to monitor this, right? So SLA is mainly useful in financial things or in some kind of live analytics things, right? Where some teams is already waiting for your data. If something is not arrived inside that bucket, they of course going to be complaining about this. This data is not available in my bucket. Why? Alerting of time or correctness of SLA are met or not, easily scale for growing a load. Executors. So when I talked about executors, so it's like you can just think is like one kind of JVM. So environment where this task is going to be run. Uh, By default, if you are running this Airflow in your local, so it is going to be used local executors or salary executors. There is also Kubernetes executors. If you are planning to run on Docker and there will be lots of Kubernetes pods, you can use Kubernetes executors for parallel processings. It will be drastically going to be enhance your performance. Sequential executors, if you want everything should be run in only sequentials, not on anything in the parallel, so you can use sequential executors. There are also some other executors available in Airflow. Airflow behind the scenes. So what happened exactly? Okay. Uh, so I already talked web server, metadata scheduler. So let's go to one by one component. Web server. So it is responsible for Airflow UI. So it is only able to show you some kind of UI. I guess in the Java there was like some servers was there, Tomcat, such kind of things were. So you can run your servlet or JSP page on top of that. So it is going to be show you that page. Second thing is metadata. So I already talked like metadata is you can consider SQLite or PostgreSQL, which is going to be stored each and everything about your DAGs, cycles, runs, retries, all these things. Scheduler is responsible for distributions of tasks over the different workers. It also responsible for meet the SLA, responsible for run particular task when the intervals is arrives. Okay, let's view the Shiny UI. So many things is might be bored in the morning. Okay, so let's go to the demo. Okay, so before that, I am going to show you the Docker instance. Can someone please confirm that is it visible properly, the Docker and UI?
Yes, it is.
Okay, thank you. Okay, so when I just put up this Docker Compo job, it has started this many tasks or nodes behind the scene. You can see that POC EMR Airflow. This is my project. Okay, it has started Postgres server for database metadata. It has started Radish for caching. So I'm not going to talk with this. Triggers. So triggers means like uh, different triggers rules are there. When it should be start running. Scheduler. So as I already talked, there is a like metadata and scheduler server, web server. So this is a Flask server running on port 8080 for showing the UI. Flower is again one kind of when you want to execute multiple things in parallelly. At the time, Flower is going to be helpful. Okay, so this is a beautiful UI. Okay, here so many things is there. Let's go to one by one. Okay, so first is DAGs. So this is a home page. Second is security. This is my local instance, and right now I have only single users inside that. So it is showing that Airflow admin Airflow. Okay, and this is a email address. Like if your company or data engineering team has 10 users, you can just add here some users, their username, password, all these things. Roles. So here like admin, public, viewer. So these are different default roles. I didn't change anything. User statistics, it is also providing like what many number of users, how many times there is a login counts, login fail count, all these tips. Okay, now these are the tags. Whatever you are seeing here, particular rows, these are the tags. Here it is showing that its status. Okay, so this is basic XCOM tag. It is showing that this is 3 times success. This is demo EMR tag. It is showing that 1 time fails. Uh, it is showing that last run here when it was last run. All these statistics. Next run. So when it is going to be run the next. This is so many things here. Okay, let's go to here. First thing is that recent tasks or none. If some task is removed from particular tag, if some task is scheduled, skewed, running, like if something is like 1 hour's going to be execute that task. So it is also showing that how many tasks is currently running. Success, currently success is total 5 tasks. Here you can see one failed task, up for retry, up for reschedule, upstream failed, something is failed upstream. So this is different things. Some sensing things skipped if some task is skipped. Okay, let's go inside DAG view. Here again, like tree view, graph view, all these things is there. This is this has only single task, so it is not properly visible. It has only like task A. Here either tree view you can execute or you can execute as a graph view. Okay, uh, I'm start enabling this DAG here. Okay, so just enable this button and let's wait. Here it is showing that schedule interval. So it is showing that 1 day. I had scheduled it for 1 day and it should be started 00. You can see that here some types of task instance is going to be executed here. Task instance will be start here. Okay, now its state is success. Also, you can see here that all the statistics is here. Like I had hovered it over there. You can see the status is success, run ID, duration 1 second it has run, date interval, UTC interval. So it is giving you time either in UTC or ITC. If your timing is ITC, you can change it to ITC or UTC. Here it is graph. This is a very simple task. I will show you its code. Uh, Here the tab is code. So very simple things. I will also walk you through all these things. Very simple task. I will just click on this. It is again going to be give me so many inference. I can click on the log. If I want to see the log. So it is saying that marking task as success. This is my DAG ID. This is task ID. This is execution date time, start time, end time. All the statistics is here also. All the thing in the logs as well. Okay, and let's move to some another DAG. Okay, here in past I run this for 3 times. So you can see that. Just a minute. Okay, so in past I run this task for multiple times, so it is showing that it is already exist for 3 times, and you can also see that it's run times, run IDs, all these things at different time intervals. I made it. It should be run at daily. So once I will just start it. If it doesn't run for today's run, like today's 2nd Feb, it is going to be executed. If it is already there, the run instance is already there, it is not going to be executed. Now, it might be possible that we want to do external run out of this schedule. So you can just click on here, trigger DAG. So it has started something. You can see a new instance is started. It is going to be now in green. It is going to be green. This task is run for 3 seconds. Again, it is something is in green. Light green means it is running. Everything is dark green means everything is success. Okay, so you can see this, all these things, all the task is going to be run and it is success. You can also see the flag here, success. Now let's go to one by one. What is this exactly? Actually, it is like nothing more fancy. What I am doing that I wrote one bash command here and I said that sleep for 3 seconds. So it will wait for 3 seconds. Then these three parallel tasks, training model A, training model B, training model C. This is nothing, just some Python function, so a simple function and choose model. So I will just getting some statistic out of them. Let me first show you its code. Okay. So this is the DAG. This is some default imports. You are importing DAGs, bash operators, Python operators. Okay, same as in some another language. So it is very simple. This is some default arguments. So default arguments, I am saying that it should be start from 2020 1st of January. Okay, my DAG default date should be started from this. There are other default arguments as well. Here is a DAG, main DAG definition. So you are defining that this is my DAG ID. So this is a DAG name which is visible in the UI basic XCOM DAG. So you can see here the basic XCOM DAG, the same one. Then you are defining that schedule interval. So schedule interval I defined it like at the rate daily. If I will just change it like 00 star star star. So it is going to be execute 00 UTC time, midnight UTC. Default argument that already I had defined here, so it is going to be referenced here. Ketchup, I will show you like what is exactly ketchup is there. So before ketchup, I have to change this, otherwise it is flooded with lots of tasks. Ketchup means that it is comparing with this date, start date, and it will catch up all the past which is going to be in between, right? Something is going to be left, right? So let's say from 1st of January to today's date is 1st of February. Okay, and I had run only for 3 times. There are still near to 27 or 28 DAGs that didn't run in the past. So let's just show you what is catch up exactly. So what it will do that it will start from 2nd January, 3rd January to the today's date. It will create that many number of DAGs, that many number of sorry, not the DAGs but task instances. It requires some times near 2, 3 to 4 minutes. We can change the times to reflect that changes into this UI. Now my change is reflected. I set it that it should be run at every minute. Okay, and you can see that it has automatically started so many things. So many DAGs is already started automatically just because of that catch-up parameter. So I set it that it should be start from 1st of January 2020 to the today's date, and it should be run at each and every minute. So it right now comparing with all these Mr. task instances, and it is trying to automatically trigger that right now. So you can see that there are lots of tasks is going to be executed at each and every minute. So this is a catch-up parameter. I have to stop it, otherwise my system will be blocked. Okay, so here you are defining some DAG, and after the DAG, I'm defining that very bash operator. So I'm just saying that sleep for 3 seconds, nothing more. So it will wait for 3 seconds, and after that, it will be executed as success. Second is training model. So I'm defining that I want these three tasks A, B, C, and that task should be of Python operator, and it should call this function training underscore model. So very simple function training underscore model. So I'm just getting some kind of random numbers between 0.1 to 10. I am printing that number and I am storing that number into one kind of variables. It is XCOM. When you want to share some things between these tasks, so you can define that things into the XCOM. So it is like one kind of pool where you are pushing some kind of things. So I'm storing that things into the XCOM. Last is Suge model. So it is again like simple Python function. What it will do that it will fetch all the things from XCOM. This is a key training model A, training model B, training model C, this key, and it is going to be fetch these things from that, and it will show you on the logs. Okay, so let me show you that things properly. Okay, if I will go here, choose model, logs. So here you can see that it has printed that statement like model 1 accuracy is this, model 2 accuracy is this, model 3 accuracy is this. This is training model A, training model B. Again, you can go to here and you can just check its log. So it is saying that model's accuracy is this and return value is this. You can see all the XCOM values here. So you can see this is like some kind of things where you want to share something between two tasks. So this is my key and this is value. It could be multiple key. It could be, it should not be a unique. It is fine, right? You can store so many things with the key value pair. It will store the timestamps, all these things. Okay, let me show you one important demo again. Okay, so demo S3 sensor, what is this? So it is going to be weight something. Uh, Inside that, let me first quickly show you the code. Okay, this is again default imports. Uh, Here I had defined so many default parameters. I am saying that this is the owner of Airflow, depends on past true or false, start date, email. If something is going to be failed, then you should be send email or not. Email on failure, email on retry, retries try. So if something is failed, one task is going to be failed, it should retry 5 times. Retry delay. So I'm saying that it should be executed after 5 minutes. Okay, this is a DAG definition. So I'm defining like whatever the file name is there, it should be a DAG file name, DAG name. I'm defining the default argument. I'm defining schedule interval. So it should run at every 5 minutes. Catch-up is equal to false and some tags. So tags is for identification purpose, segregation purpose. Here's one basic task is like T1 bash operator, nothing. It is very simple. I just printing something. S3 key sensor. So this is going to be real-time check inside this folder. This is my bucket, S3 bucket. Inside that bucket, it is waiting for this some .txt file. Until and unless I will not put this txt file, it is not going to be success. It will continuously watch over there. I am defining this is my AWS default connection. And at the last again, this is a bash command. I'm just printing something. Okay, I had just enabled it. Let's see if it has something unrun. Yeah, it has already started new run. Now you can see here it is light green. So it is continuously watching. It is waiting for my bucket. Until and unless I will not put .txt file, it is going to be continuously wait over there. It is not going to be move further. It is not going to be fail. You can go here and check its log. It will show you some POC intervals after some times. So POC intervals means that you can define something should be continuously wait, but at interval like 2 seconds, 5 seconds, 5 minutes. Okay, this is my S3 bucket Airflow demo Chetan. Okay, when I will put something .txt file inside that. See, the task is done just because it was waiting for that particular .txt file. You can see that poking for key. So it was waiting for this bucket and for this start.txt. So this is a thing like you can utilize it in different ways. This is again some statistics. You can see all the things like upstream failed or how many success, what is the schedule interval. Okay, one thing, let me show you one more thing. Okay, this is some chart here, task tries. So if some task is how many times it has retried, landing times. Here I don't have much task. Okay, let me show some another deck. Okay, so here you can see that this showing some kind of times versus dates for particular task, like training model A, training model B, how many times they required for particular task. Here so many things is there. You can update this graph at runtime. Then Gantt chart. So this chart will showing that, yeah, you can see the download data. It's always required 3+ seconds. Other task is like training model B, training model A, C. So this is a duration. It is showing that this is required this many times. Details for about that particular task, deck details. So it is saying that honors, catch-up is true or false. All this type of metadata it is showing. And final tab is code. So whatever you write over that, it is going to be visualized here. Calendars, so throughout the year, how many times on what day, how many success failures, all these details is okay. So now one question is here, like all this data, where this data is fetched, where this data is stored and why it is fetching something, right? So all this data is already stored in the metadata, either is PostgreSQL or SQLite, whatever you can define inside the Airflow configurations. Okay, I guess I heard you so many things. Okay, one important thing is here. Inside the admin, there is one tab is connections. Someone has might be questions like how my local Airflow is connected with my AWS. So here you have to define connections, AWS default. So this you can type it any name. I just pasted some key value pair and region, all these things. So this is the way like it is attached with my AWS account, this local Airflow instance. In productions, like when we are running these DAGs in data science pipeline or data engineering pipeline. So in productions, this is like some production graph. I will show you just what we are doing is like we have some PyPark script, right, or Scala script, which we wrote for big data operations, transformations, or ETL pipeline. First, we will upload that file to S3 server. Then we will create one EMR clusters. So EMR cluster is Airflow service. So it will spin up some number of clusters for us, and it will show that the task is going to be run on that. We are doing some kind of utility functions like moving Spark job, then run what are the in the EMS clusters we have to add some kind of steps. So we are adding some steps, and after that we are terminating this cluster. So this is like one kind of productions flow which we are generally using in the data engineering pipelines. Basically, it is already using same kind of stuff, same kind of operators and all these things. Nothing new fancy. We have to just manipulate some kind of things, and you have to read some kind of documentation for different operators. Okay, that's lots of things about the Airflow UI. Let's move again to the PPT part. Okay, applications. So application I have already shown like ETL pipeline, machine learning pipelines, some predictive analytics, fraud detections or anomaly detections. We had talked to so many advantages of and now it's time for limitations as well. So this Apache Airflow is not for data streaming application. Like if you're planning to do some kind of streaming applications and you want to do some kind of real-time analysis on top of that, so don't do this. This is not data streaming solutions or data processing solutions as well. Second thing is that right now, as of now, Apache version 2, Airflow version 2.3, there is no version control of DAG. Uh, Contributors is already trying to add some kind of version controls in upcoming release. No mechanism for sharing the data between tasks. I shown you the XCOM. So XCOM has limitation. You can share only 2 MB of data, but you cannot share like pandas data frame or such kind of more than 2 MB of data between tasks. Again, it is not recommended things for sharing the data between tasks. Airflow is not designed to execute your data pipelines directly. So you cannot do some kind of operations directly on the Airflow. Airflow is just orchestration tool. You have to do that task either in AWS or GCP or Azure external services. Don't do any kind of processing things in the Airflow. Uh, Again, support only for Python. For someone's it is benefits, or someone it is not. Like if Scala developers is trying, then they